Simplified Organic. So today I'm going to discuss about structure of SO3, sulfur trioxide. So sulfur trioxide generally we draw in this way as double bond O, double bond O, double bond O, and in this you have three sigma bonds. We have three sigma bonds and three pi bonds. So in these three pi bond, what are different types of pi bonds and what are different types of sigma bonds in this case? I'm going to discuss now. So please be with me for very important concept. What type of pi bond you see in SO3? So sulfur atomic number 16, neon electronic configuration 3s2, 3px2, 3py1, 3pz1. So in previous lecture I taught you already that the number of unpaired electrons needed is equal to total number of bonds. So I'll write here 3d z square 0, 3d x square y square 0. So total number of unpaired electrons required is equal to total number of bonds. So now you see the structure of SO3, the total number of bonds are 6 bonds. Total number of bonds are 6, right? So I need 6 unpaired electrons. So what I'll do, so the total number of 6 bonds, so I need 6 unpaired electrons. So I'll go for excitation of electrons. In the first excitation, I'll get 4 unpaired electrons. In the second excited state, I'll get 6 unpaired electrons. So what will be the configuration in case of second excited state? In second excited state, the configuration is 3s1, 3px1, 3py1, 3pz1, 3d z square 1, 3d x square y square 1. So total number of unpaired electrons are 6. So this is d orbitals. So 1, 2, 3, 4, 5, 6. So total number of unpaired electrons are 6. Now what is our second step? This is the first step what we have done. What is the second step? The second step is out of 6, how many? So total number of orbitals under hybridization is equal to total number of sigma bonds plus lone pairs. Anyway, in this structure of SO3 there are no lone pairs and there are 3 sigma bonds. So I need 3 orbitals in hybridization. So out of 6, 3 orbitals will undergo hybridization. So 1s and 2p, 1, 2, 3 orbitals. So hybridization is sp2. So it's sp2 type of hybridization. I'll write it here. It's sp2 type of hybridization. So after hybridization, you get hybridized orbitals, right? So you get hybridized orbitals. So these are hybridized orbitals. These 3 are sp2 hybridized orbitals with 1 electron each. And now what about these 3 electrons which are not in hybridization? These are pure orbitals. What do you mean by pure orbitals? Which are not in hybridization. So now these 3 electrons will form pi bonds with oxygen. See, there are 3 pi bonds, right? The 3 pi bonds. So these 3 pi electrons will form pi bond with oxygens. Okay. So now, if I draw the complete detailed structure of SO3, this is the sulfur, oxygen, oxygen, oxygen. So the sigma bonds which are formed here, the sigma bond are because of the hybridized orbitals. This one, okay. The sigma bond are because of the hybridized orbitals. So what kind of bond is this sigma? This is sigma sp2 hybridized orbital with p orbital of oxygen. So it is sigma sp2 p type of bond, all the 3 sigma bonds. Now these pi bonds which are formed here, if you check properly, one pi bond is because of the overlapping of p orbital of sulfur. See, this is the p orbital and these are d orbitals. So one pi bond is because of the overlapping of p and p of oxygen, and the remaining 2 are because of the d and d orbital of sulfur and p orbital of oxygen. So though these are pi bonds, these pi bonds are different. So one pi bond, I can say that one pi bond is p pi type of pi bond, and the remaining 2 pi bonds are d p pi, because d orbital of sulfur is combining with p orbital of oxygen. So d pi p pi. So now the question is what kind of sigma bond you see in SO3? So that is sigma sp2p type of bond. And question is second one, how many, this first one, second one, how many kinds of pi bond are possible in SO3? So the answer is 2 kinds or 2 types. What are those 2 types? One is p pi type of bond and other one is d p pi bond. What is the hybridization? sp2 type of hybridization. So the shape is trigonal planar. So this is the structure of SO2. So in SO2 you will find different types of pi bonds. So that is very important. And what kind of hybridization it will show. And this question can also be asked, in which excited state it is undergoing hybridization. So the answer is in the second excited state. Why I am doing excitation 2 times? First excitation, then second excitation. All because I need 6 unpaired electrons. So that is about the structure of SO3. So please keep watching my videos for more and more discussion on structure of different compounds in chemical bond. Thank you very much. Please subscribe, like my channel. Thank you very much. Bye bye. Take care.